Law of cosines. First of all, I'm going to tell you this right now. And I might change my mind hold on. But for your WebAssign, just for the law of sines, why is this not writing? Here we go. For the law of sines that we're about to do, law of cosines, right? You just need a PDF. So you can download the homework problems into a PDF, do all the work, and submit it. You don't have to put it into WebAssign. If you want to check, that's fine. But what happens with this is there's a lot of places, like with the law of sines problem, if you do like I said yesterday, you do everything, and then at the very end round, you should be fine. But here, there's sometimes where we have to round, and then you're going to have to round again in the problem. And the more you round, the further away you get from the exact answer. So, all right, your law of cosines, guys, there's two forms. There's the standard form and the alternative form. They're the exact same thing, just one is manipulated to work for side lengths, and one is manipulated to work for angle lengths. So look, this is if you're looking for a side length, right? A squared, B squared, or C squared. And then this is if you're looking for an angle. Do you see how it's cosine C, cosine B, cosine A? It doesn't really matter which formula you use. They're the same. Just notice that in the one where you're looking for a side, the side you're looking for is going to have the cosine of the angle. Because remember, sides are across from angles, right? So if I'm looking for B, you're going to use the cosine of B. If I'm looking for C, you're going to use the cosine of C. You just got to pay attention to that. Same thing with the angle one. If you're trying to find the angle for A, look, it's the one that you subtract in the formula. If you're looking for the angle of B, it's the one that you subtract. If you're looking for the angle of C, it's the one that you subtract. Does that make sense? You're going to always add two sides and subtract one of them. Whatever angle you're looking for is the side you subtract. Now, when you find the angle here, when you find this angle, are you actually finding the angle? When I say cosine of A, is that the angle measure? It's the cosine of the angle. So what are we going to have to do in our calculator? Cosine -1. Very common mistake is you guys do this. You get the cosine of A as something, and then in your calculator you hit second sine. Are sine and cosine the same trig functions? No, so just pay attention to what you're doing. So, first example. The reason we use the law of cosines, and generally what you do is you use the law of cosines for the first step, and then you're going to use the law of sines for the second step. But the reason you have to use the law of cosines, when we use the law of sines, remember from yesterday, what do we need? We need a side and its corresponding what? Angle. What did they give us here? 3 sides. This is why, God bless, oh, never mind. This is why you have to use the law of cosines, because you don't have an angle measure. All right, does that make sense? Okay. Again, I told you yesterday, it'll say in the problem, using the law of cosines, so it'll help you. But what you guys need to remember, and I kept this here because this is really important, very important. You have to find the angle of the opposite the longest side first. Always find the biggest angle or the longest side first. If not, what happens is your angle measures will come out not proportion to your triangle. Meaning, if you found A first, right? Look at A. A is what? The smallest or the biggest? Smallest angle. How do you know it's the smallest? Because it's across from the smallest what? Small side, right? What's the smallest side? 8, 14, or 19? 8. The smallest angle is across from the smallest side. So if you don't start with the largest, what will happen is mathematically you throw it into the formula and you will not get that angle A is the smallest. It might end up where it's the middle side, and that doesn't make mathematical sense. So you always, always, always start with the longest side or the biggest angle. So in this case, what is the biggest angle? B. How do I know B is the biggest? Because it's across from the longest side. So we are trying to find angle B, so you're going to use this formula. The cosine of B equals, now you just fill in the information. What is A? 8, so it's 8 squared plus, what is C? 14 squared, minus B, which is 19 squared, all over 2 times 8 times 14. Now, nothing is hard about this. Entering this into your calculator, you guys might have some issues. So here I'm going to tell you how I think is the easiest way to do it. All right, we have the cosine of B. Simplify the numerator first. Do just the numerator. So 8 squared plus 14 squared minus 19 squared. What does that give you? Say it again. Do it again, Chris. Negative 101. Did you add them all? I don't know. Just throw it in there again. And then on the denominator, what is 2 times 8 times 14? 224. Everybody with me? 224. Why won't my Apple Pencil write? Okay, so 224. Everybody with me? All right, so let's go a little bit more. Cosine B equals, what's negative 101 divided by 224? Negative 0.45089. Right? Is that the actual angle measure? No. How do I find the angle measure? Second cosine, second answer, and I get what? All right, so we got angle B was how much? 116.8, okay? So I found out here, guys, angle B is 116.8 degrees. All right, we're solving this triangle. I already know all 3 sides, so what am I looking for? The other what? 3 angles. So now I have to find B, then I'm going to find C, and then I'm going to find A. Absolutely, that's what I was just going to say. So look what we just found. We just found that angle B is 116.8, right? Could I go ahead and use the law of cosines again? Absolutely. But what would be easier? What did Alex just tell us? Wait a second. Now I have an angle measure and its corresponding side, correct? So what could I use? The law of sines. Let's go ahead and do that. So I'm going to say the sine of 116.8 over 19 equals, let's find the next biggest. Always go in order. Find the biggest, then the middle, then the small. So I have sine of what? Sine of C, good, over 14. How do we do this? We do this like we did 100 times yesterday. 19 times the sine of C equals 14 times the sine of 116.8. Divide both sides by perfect. So the sine of C is what? 14 times the sine of 116.8.
0.65. You have to do the inverse now.
What'd you get? Say it one more time.
0.65.
6.5 what? 4 decimal places.
6.576.
Okay. And now we hit second sign. You can hit either second answer or you can just plug in 0.6576. 41.1. So angle C is 41.1 degrees. Make sure you put your degree mark. So look over here. I'm going to say, okay, angle C is 41.1, we said, degrees.
Do we have to show flipping into the inverse or can we?
No. Yeah. 41.1 degrees. All right. Now, how in the world, guys, can I figure out? I'm going to add 116.8 plus 41.1 and get what? How much? No, what's that together? 157.9. And then I say 180 minus that, and I get what? 22.1 degrees. All right, we have solved the triangle. When they give us the 3 sides, this is super easy. How can you check to make sure you didn't make a mistake, you didn't plug in something wrong, you didn't solve for the wrong angle first? The longest side is across from the biggest angle. The smallest side is across from the smallest angle. What's the smallest angle here in our list? 22.1. Is that across from the smallest side? Yeah. You're good to go. All right, let's look at this one. How's this one a tad bit different? They gave me 2 sides and an angle. All right, guys, do I have an angle and the side across from it, and then we could just go ahead and say, oh, it's the law of sines? No. What can we do? What should we solve for? Why A? Right? Look, do we already have B and C, and we have an angle, right? So which formula are you going to use? Don't get hung up on, I don't know which letter. What angle do you have? A, right? So then we're going to look for what? Side A. So I'm going to say, okay, A squared, right? That's what I'm looking for, is A squared equals B squared plus C squared, B squared plus C squared minus what? Minus 2BC cosine A. What did I tell you at the beginning? The side you're looking for is going to go with the angle that you're given, right? Okay, so you can make sure that you have that right. Now just pay attention to the numbers. What is B? So I have 9 squared plus what's C? 12 squared minus 2 times 9 times 12 times the cosine of 25. Calculator work. Yeah.
I missed how you like chose out of the equations, like which one you used.
Okay, well, what's the only angle you have?
Oh, the 25.
What angle is that, though?
A.
A. So I just picked this one because it has the cosine of A.
So whatever it. Like,
Whatever angle is given, just use that. Yeah, because you don't have B or C, so you couldn't use the cosine of B or C.
Okay. Thank you.
Mhm.
Okay.
Uh-huh.
What would be given visualization?
Yeah. This is my suggestion to you. Some of us, our calculators don't all work the same way. Some of our fingers don't all work the same way. So I would simplify this first. What's 9 squared plus 12 squared? What was that? Did you just see that?
Yeah.
9 squared plus 12 squared is what? 225? Okay. Minus. Do you see that minus sign there? Okay, so now let's say 2 times 9 times 12 times the cosine of 25. Let's do 2 decimal places. 76. Do you see why this is a little harder to put into WebAssign? Because what is that decimal that you got there? 195762482, right? Yeah. If somebody rounds to 76 and somebody rounds to 0.8, that's going to change how we're going to then have to round again in a second. So that's why it's easier to just do this as a PDF. Guys, sometimes when you simplify this, and you'll see here in a minute, sometimes when you simplify this, you get a negative number. But do you notice this negative sign here? If I have minus a negative, what does that become? Plus. So just be careful, all I'm saying. So now 225 minus 195.76. So I have A squared equals 29.24. Is that my answer? Why not? You got to take the square root. So again, what are we going to have to do here? We're going to have to round again. That's why I say to do this as a PDF. What is the square root of 29.24? So 5.41. Okay. It's plus or minus, right? How come we don't use that? Because we're not talking about length. So think about the things we're trying to find. We're trying to find little a. Then we're trying to find angle B and angle what? Okay. Did we already find little a? Yes, it was 5.41. Well, since now we have that a is 5.41, what else do we have? What do we have now to use? The law of cosine, right? We can say, oh, I have an angle and its corresponding side. So I'm going to say the sine of 25, over 5.41 equals, what do you want to find? Okay, let's find B. So sine of B over 9. Cross multiply. So I have 9 times the sine of 25 equals 5.41 times the sine of B. Divide both sides by. So I have the sine of B equals, what's 9 times the sine of 25 divided by 5.41. 0.70306. right? So is that the answer? No, second sign, second answer gives me that angle B is 44.7. You guys agree? Now, how can I find C? I just add the two. I have A is 25 plus B is 44.7, which gives me 69.7. And then I say 180 minus. All right, now do those numbers make sense? What's the biggest angle? How do you know? Just by looking at this triangle. Not because it looks the biggest, but how do you know it's the biggest? It's across from the longest side. When we did our calculations, what was the biggest angle? When we did our calculations, which one's bigger? A, B, or C? C, okay? Let's do something real quick. I'm going to do this just because we're on the video. Say somebody in here said, well, I don't want to find B next. Say you wanted to find C. Right? Okay, so let's see what happens. You don't have to write this down. You can just watch me. So we'll say sine of C over 12. Just do the calculations for me. So cross multiply. I have 12 times the sine of 25 equals the sine of C times 5.41. And then divide both sides by 5.41. So sine of C equals. What is 12 times the sine of 25 divided by 5.41? 0.9374, right? So second sign, second answer. I get angle C is 69.7, okay? Is that the same answer? No. Does that make sense, guys? Think about this. If angle A is 25, and you said angle C was 69.7, that means angle B is, what's 25 plus 69.7? This is 94.7, so then 180 minus 94.7 gives me 85.3. Yeah? Well, guys, think about the picture. Think about the picture. What is the longest side? C. So what should the biggest angle be? C. Does this mean my calculations are wrong? No. What does this mean? No, not that you put it in wrong.
The triangle can't be.
There's a what, my dear? There's a second triangle. Oh, that means there is a second triangle. But I'm not asking you to solve. Only time we were looking for a second triangle is we're doing law of sines. So I'm not, what you need to be aware of, guys, is we are solving this triangle, correct? So with this triangle, which angle should be the biggest? C. Why? Because it's across from the longest side. With what is given here, if this is given to you, then you need to solve this triangle. So why is this important? What am I bringing up to you guys? We solved here for the what? Smallest or biggest? That's the smallest side, right? So then we found which one next? What did we find here? The middle. Then we found the biggest. I told you at the beginning, if you are looking for an angle, find the biggest one first. Always go in order. If you're starting with the smallest, then go to the middle, then go to the biggest. If you're starting with the biggest, then go to the middle, go to the smallest. That makes sense? It's not that this is wrong. It's that you solved the second triangle here. You discovered there's a second triangle, but it does not match these side lengths. You'd have to go back and solve to find the other side lengths. Does that make sense? So what I'm saying is just check. Check to see if what you found matches the picture. This over here does not match the picture because it's not the same picture. This is a second triangle that could possibly exist, but not with these side lengths that are given. Make sense? Okay. Good. All right. Pitcher's mound on the softball field. Where are you going? Pitcher's mound on a softball field, right? This is where this is like an applicable thing. I did not pick this. This was just in the book, so it's kind of funny. But the pitcher's mound on a softball field is 43 feet from home plate. The distance between the bases is 60. All right, the pitcher's mound is not halfway between. They want to know how far is the pitcher's mound from first base. So look at what you have here. Do you see the triangle? Do you guys see the triangle? Okay. What do we have? Two sides and an angle. The reason I like this problem is because it does not use A, B, and C. So think about what you have here. You have 45 as the angle, right? And you have H. You can change that to whatever letter you want, guys. Make it an A, make it a B, make it a C. What do you have here? You're looking for the side length. I'm going to use H. What do we do with the two sides that we have? Those are the ones that we add, right? And then we have the cosine of 45. So what angle? How is this going to look? Tell me the formula. Plug it into the formula. It doesn't have A, B, or C. You guys can pick. It doesn't matter. Make H whatever letter you want it to be. So what are you going to write? So B squared plus C squared. Do you see why the letters are arbitrary here, guys? Whatever the side is you're looking for goes with what? The angle that you have, right? Guys, do you understand what I'm saying? So if this is confusing to you, what do you do with H? Change it to a what? An A. I want you to see that. Don't get hung up on, I don't know which one's A. Whatever side you're looking for goes with the angle that is given. So let's throw this in here. Does it matter which one's B and which one's C? No, you're squaring them and adding them together. Who cares? You're multiplying them the other one. So let's go. What's one of them? 43 squared, okay, plus 60 squared minus 2 times 43 times 60 times cosine 45, all right? We're probably going to have a ginormous number here. That's okay. Let's simplify this first part here. 43 squared plus 60 squared. So 43 squared plus 60 squared is, whoa, 5,449 minus, what's 2 times 43 times 60 times the cosine of 45. Does that give you? 3,648 point, let's say 67. Okay. So 5,449 minus 3,648.67. I got 1,800.33. That's your A squared, H squared, whatever squared. Is that the answer? Is the pitcher's mound 1,800 feet from? No. Take the square root. So the pitcher's mound is about, how long? 42.4 feet. Scrubs, did you know that?
I did actually.
There you go.
I know I did.
Oh, I'm not done. Wait a second. Alec, look through the notes, honey. You see there's another example. What's going to be really important when you guys are doing this stuff? Paying attention to your fingers in the calculator. Do you see what a big deal it would be if you switched an 8 and a 2? Right? If you miss a decimal point, that's a big deal. All right, now we're going to talk about our friend Heron and his formula. You guys will be given this. It's super easy. Here is the formula for Herons. It's the square root of S times S minus A times S minus B times S minus C, where S equals this. All right, you guys are like, huh? Here's a problem. Why can I not use my formula from yesterday? What do we need for a formula from yesterday? An angle where? Got to be in between the sides, right? Well, we don't have that in this case. We only have 3 sides. So Heron's formula says to take the 3 sides and do what first? Add them together and divide by 2. Here is the big deal, guys. Does it matter which you put where? No. But understand, you have to tell the calculator, hey, calculator, add all the stuff in the numerator first, then divide by 2. If you just put it in 53 plus 72 plus 43 and then hit divided by 2, what your calculator will do is divide 43 by 2 and then add the other stuff to it. So if I were you, just to make sure we don't make any mistakes, I would say the numerator, 53 plus 72 plus 43 equals 168, and then divide that by 2. What's 168 divided by 2? 84. So S equals 84. Now, Heron's formula says the area is the square root of, you take your S value, which is 84, and then you subtract 84 from A, B, and C. Doesn't matter what order. So I'm going to say 84 minus 53, that's one of the sides, right? Times 84 minus 72 times 84 minus 43. Now again, the reason why this is going to be done in your calculator and then on a PDF is because some of you will put all of this in at one time and get an answer. Some of you will do piece by piece by piece by piece, and then it depends on however you do it, you'll be rounding at different stages. So I'm just going to go ahead and simplify here just so you guys can see everything. What's 84 minus 53? 31. What's 84 minus 72? 12. 84 minus 43 is 41. Yeah? What do I do with all those numbers? 84 times 31 times 12 times 41. 1, 2, 8. 1, 1, 6, 8. Yeah? Now take the square root. So the area is about 1,131.9 what? Meters squared. Perfect. I'll tell you on the quiz what I want you to round to. Right? And then the last, all it does is just talk about the three formulas. Standard formula, this is for a right triangle. This is an oblique triangle when you have two sides and the angle where? Angle in between. And then the last one is when you have what? Three sides. Right? Okay.